class. This is a little help guide video, I guess, for lab number 4, which is on volcanoes. So I'm gonna hopefully take you through what you need to know or what you may struggle with the most in this lab as we go. So just as a clarification, this lab was created by Mark W. Bowen from the Department of Geography and Urban Planning at the University of Wisconsin in Oshkosh. But it has been modified by me, Gabriela Boyland, from the College of Western Idaho. So if you need help, please don't hesitate to ask me. I'm going to go ahead and skip through the goals for the lab and essential learning outcomes. You are free to look through them later. The equipment that you need. So you need a ruler, a calculator, and a computer with internet access and a printer. You can do this without the ruler and without the internet, without a printer. However, I do recommend that you use it. It makes things a lot easier. I'm going to show you how to do it not using it, as I can actually show you on the screen. But again, it makes it much easier if you do use a ruler and you print your maps. So I'm going to also skip through the background information. So the background information is about the 4 different types of volcanoes that we have. So those being cinder cones, stratovolcanoes, shield volcanoes, and lava domes. I'm going to skip through this first part. However, as you can see, stratovolcanoes and shield volcanoes are the main descriptions here in the background, and you should totally read through them so that the rest of the lab makes a little bit more sense. We're going to be dealing with 2 main volcanoes. One is a stratovolcano, namely Mount St. Helens, and the second one is a shield volcano, namely Mauna Loa, which is in Hawaii. So read through it. Okay, so the first part. What I ask you to do is the first part is going to be based on stratovolcano and shield volcano morphology. What I ask you to do is print both of the maps that you're going to see, figure 1 and figure 2. So this is figure 1, and then later down below, this is figure 2. You should print both of them. It's going to make it much easier. But this first map is the topographic map of Mount St. Helens prior to the 1980 eruption. And you will use it in order to answer the questions that are below. Okay? So, before you, or after you have printed that, but before you go ahead and tackle the questions, a lot of these have to do with contour lines and contour intervals. So you're going to have to do a lot of topographic map analysis. So if you're not familiar with topographic maps, which probably most of you are not, I would recommend you go on Blackboard. So here we are on Blackboard. If this is the lab, right? Week 4, lab 4, volcanoes. This is your checklist, the instructions. Here, a little bit below, is a video that I have for you. It's not mine, but the instructor who does this video is very good at explaining what topographic maps are and how you can calculate easy things like contour interval, index contours, so on and so forth, the rule of V's. I really like his approach. So please watch it. At least the first, I think, 7 minutes or so are going to be incredibly helpful in order for you to go ahead and tackle this lab. So again, just click on the link. Video pops up.
Hi everybody. Today we're going to take a
and
look
here it
at
is.
topographic maps. So right now you're looking
Okay.
at a topographic
So I'm not going to go ahead and play it for you now, but again, if you need extra help on understanding topographic maps, do look at this video again at least until minute, I think it's about 7 or so. Everything's going to be useful. After that is just practicing different skills which you may be interested in, which is perfectly fine, perfectly reasonable. If you're still struggling even after watching up to minute 7, I will watch the whole video, or I would ask me any questions that you may have, and I'm happy to either answer them through email or to set up a time on Blackboard Collaborate and we can chat about it. Okay? Alright. So again, that's just here, video introduction to topographic maps under the weekly lab. Okay, so once you have watched that video on topographic maps, you can go ahead and answer the following questions. So, what is the contour interval of the map? So, in order to do this, what you need to do is count the number of lines between two index contours and determine the difference in elevation between those two index contours. Then you divide the elevation difference by the number of contour lines that are between them. So, or how many go from one onto the next index contour. So I'm going to help you with this first one. So let's see. All right, so here's our map. Again, it's hard to see. Oh, I'm sorry. Since it's so small, everything is so detailed. But we need to find the contour interval. So as you saw in the introduction video for the topographic maps, the contour interval can be calculated using the index contours. So all of these bold lines, or bolder I should say, lines that also have a number that is designated to them, those are the index contours. Hence the name index, right? Because they're a clue, they're a given idea of what they are. So what I would do is find two index contours that are adjacent to one another and where you can actually see numbers from one to the next. So here's a good example. This one is 5200, and then this one, which if you continue the line throughout, is 5600. So there's two index contours adjacent to one another, right? And what we need to do is now say, okay, so we have 5600 as one of them, right? Minus 5200, so that's the difference in elevation between them. So this is an elevation difference of 400 feet. And then that is the contour interval for index contours, but not the contour interval for each contour line. So how is it that we now figure out how many or what the contour interval is for each contour line? So we can again zoom into the map. Okay, so this is where we were. Again, this is 5200, this is 5600. And we say, okay, how many increments or how many contour lines do I have to go up in order to get from 5200 to 5600? So I would have to go 1, then 2, then 3, then 4, and 5. Okay, so I need to basically take 5 steps or 5 contour lines in order to get from 5200 to 5600. Which means that when I'm solving for this, I would say 400 feet that there is a difference between those two index contours have to be divided by 5 increments in order to find the elevation difference between two normal contour lines. So if you divide 400 by 5, that's a contour interval of 80 feet. Okay, that one's fairly straightforward. You will have to do the same for the next map, but I won't help you with that one because hopefully by now you can do it on your own. Okay, good. Onward. So now what it's asking us to do is measure a distance of 2 miles due north and 2 miles due south of the peak and plot an A to the north and a B to the south. So here I'm giving you a tip, and that tip is that each of the red squares represents 1 mile. So determine the elevation after you've done this plotting of A and B. Determine the elevation of the peak, determine the elevation at point A, and the elevation at point B. So I'll help you with that one also. Okay, so I have conveniently placed this little bar scale. This is equal to 1 mile, according to what I said. So again, each red square is 1 mile in this map. Cool. So let's see. So the peak is right here, right? That point of 96.77, that is the peak. So I need to go 2 miles to the north. North, in most cases, for most maps, is going to be up above. So I'm going to copy, paste that, place it right on top, basically. Good. And then I'd be placing a point named A here. Good. Make B for later. Alright. So I got my 2 miles measured to the north. I'm going to change this real fast and make it blue. And I want to measure again from the peak due south another 2 miles. Okay, and then I place that point as B. Excellent. So now, let's determine the elevation first at the peak, then at point A, and then at point B. So, we already said that the elevation at the peak was this elevation that's kind of behind, and that was 96.77 feet. I'll make this much lighter for you. Cool. Then we need the elevation at A. So let's see. So as we zoom in on A, this hits this contour interval, or this index contour, I should say, and then it goes down one more contour interval. So let's see. So this is 5200 right above it, which means the next contour or index contour, sorry, is 4800, right? 400 feet below. So if this is 4800 and we go down an extra contour interval, remember the contour intervals are 80 feet, then I go from 4800 to, hopefully you're thinking, 4720 feet. So the elevation at A is 4720 feet. So we do the same thing with B. And we say, oh, so sorry guys. And we say, okay, so this point of B reaches probably this close to bottom contour. So let's see, can we figure out what this index contour is here? So we could go around and try to figure it out, but we can also use the index contours that we do have at hand. So this is 6,000. This one right here is going to be what? It's going downhill. So 6,000 minus 400, 5,600, minus another 400, 5,200, right? And then it doesn't go all the way to 4,800, but it gets close. So it gets almost all the way to 4,800, but plus an extra 80 feet. So it doesn't go all the way. It goes down 1, 2, 3, and probably 4 contour intervals below the 5,200 line. So this contour interval where it gets to would be 4,880 feet. Okay. So now that we have those 3 elevations determined, after we have measured 2 miles to the north and 2 miles to the south of the peak, let's go ahead and continue reading to see what it is that we need to do. Okay, so the second question is, what is the percent slope of the north face of Mount St. Helens? So in order to find a percent slope, what we need to do is go, what is the elevation change over the distance times 100? So the elevation change is going to be the change from the highest elevation, which is the peak in this case, right? And we know that that elevation is 96.77 minus the lowest elevation, which going north is 47.20, right? So that's the elevation change. And then according to the formula, that has to be divided by the distance between those 2 points. So we know that the distance between those 2 points is 2 miles, or if you convert that to feet, that's going to be equal to basically 5,200. I'm gonna do it in feet. So 1 mile is 5,280 feet. So 5,280 feet times 2 is 10,560. 560. And that I multiply times 100 to get percent slope. So why did I change from miles to feet? Because I want my units to stay equal. So since this is feet measured on top, I want feet also measured here. So what do I end up getting with that calculation? I get 96.77 minus 47.20 divided by 10,560 times, so I get about 47% slope. Alright, so that would be the answer for 2. Then number 3 asks us, what is the percent slope of the south face of Mount St. Helens? So in order to do this, you use the same equation, except that in this case, you're not going to go to point A, but you're going to go to point B instead. But basically the same distance and the same high elevation. And I'll let you go ahead and do that one on your own.